Hi guys! In this video, we're going to prove the sine-angle sum identity from trigonometry. We're only going to use a few basic tools from geometry. The three basic tools we'll need is we'll need to know SOHCAHTOA, we'll need to know that the sum of three angles in a triangle is 180 degrees, and we'll also need to know that alternate interior angles are congruent. So let's begin. Let's just begin by trying to fill in as much information in this diagram as possible. So we're given this diagram, and to start, note that this length AD is 1 because we're dealing with a unit circle. Next, note that the cosine of x is the length, it's adjacent over hypotenuse, so it's the length AC over 1, or it's just the length AC. And also note that sine of x is opposite over hypotenuse, so it'd be the opposite is the length CD, and the hypotenuse is 1. So we get the lengths AC and CD for free. Next, we'll want to work with sine of x plus y. We'll want to see what we can get from this in this picture. Well, first note, the x plus y is this big angle right here. So this big angle x plus y creates the triangle ADF, and so the sine of x plus y would be opposite over hypotenuse, which would be the length DF over 1. So I'm just going to say DF. And then DF can be split into two pieces. DF is the segment DE plus the segment EF. So we'll say DF is DE plus EF. And notice this is also the same thing because we have a rectangle here. EF and BC are entirely the same, right? So EF and BC are the same because we have a rectangle by construction. So therefore this would be DE plus BC. Awesome. So we just replaced EF with BC because we have a rectangle. Awesome. So next we have that the sine of y is equal to the length BC, the opposite over the hypotenuse, and the hypotenuse is AC, but we showed earlier that AC is the same as cosine x. Therefore, with a little bit of rearranging, we get that cosine x times the sine of y is the length BC. Awesome. So we've got that now. So we know that BC is cosine x sine y. Lastly, what we're going to do is we're finally going to use the alternate interior angle business mentioned earlier. So note that in this picture, the segment AB and the segment EC or CE, both of those are parallel, right? And the segment AC is a transversal of these two segments AB and EC, right? So AC is a transversal of two parallel lines. So because of that, we know that the alternate interior angles are equal. So that means that the angle here is also y because these are alternate interior angles. Okay, but we also, by our construction, this angle up here was a right angle, right? So this angle up here was a right angle, so therefore what's missing right here must be 90 minus y. So I'll note that that's 90 minus y degrees right here. And then, so because this is 90 minus y and then this is 90, this angle right here must be y, because then you can check that y plus 90 minus y does give you 180. Awesome. So the next thing we'll want to do is we'll want to look at this triangle CDE. Note that triangle CDE has that angle y in it now. So we're going to take the cosine of y with that little triangle up there, the triangle CDE. So the cosine of y in that right triangle would be adjacent over hypotenuse. Well, the adjacent side is DE, and the hypotenuse is CD. Right? But we already know what CD is. CD is sine x. Right? So CD is sine x. So therefore we can rearrange this to get sine x cosine y is the length DE. Awesome, and now we're almost there because I'll box the relevant information we have. So we have that sine x cosine y is the length DE, and we also know that cosine x sine y is the length BC. And remember that the sine of x plus y was df. df was split into these two pieces, DE and BC, right? DE and BC. So DE and BC here and here. And we know DE is given by sine x cos y. So DE is sine x cos y, which matches with what's up here. Sorry, that matches with what's up here. And also that cosine x sine y is right here, and that's BC. So this is DE plus BC, which was EF, or sorry, was DF, and that was sine of x plus y. So that's the proof. If you have any questions about it, please feel free to leave a comment. But it's a very nice proof. It's not really that straightforward because there's this construction you have to make, so it's a little bit less intuitive. But all the while, you really just have to use this picture and then follow your nose, and then you can come up with the identity. So I thought this one was pretty cool. You can probably get the other sine difference identity, or the cosine sum or cosine difference identities, in a very similar fashion, I'd imagine, and I challenge you to try that on your own if you'd like. Well, anyway, that's the end of this video, so please like and subscribe to the channel, and I'll see you in the future.